Water is the foundation of all known life. From the tiniest bacteria to complex human civilizations, it is essential for survival. But on Mars, liquid water is scarce. The planet, once home to vast rivers and lakes, is now a frozen desert. If we are to survive on Mars, we must unlock its hidden water reserves and do so with precision, innovation, and sustainability. Despite its dry, dusty surface, Mars still holds a significant amount of water. The two primary sources we can tap into are the polar ice caps and subsurface ice deposits. Scientists have confirmed that vast quantities of frozen water are locked within the Martian soil, some buried just a few meters beneath the surface. Accessing this water is one of the greatest challenges facing future colonists. Let's explore how humans could extract and utilize it. The Martian poles contain millions of cubic kilometers of frozen water mixed with carbon dioxide ice. While this reservoir is immense, melting it isn't as simple as applying heat. The extreme cold and low atmospheric pressure cause most water to sublimate directly into vapor rather than remain liquid. One proposed method is deploying massive orbital mirrors to concentrate sunlight onto the ice caps. By gradually increasing the temperature, the process could trigger a controlled release of water vapor into the thin atmosphere, increasing its humidity and potentially forming small clouds. A more controlled approach would be direct ice mining. Robotic excavators could extract blocks of ice, transport them to insulated processing plants, and melt them in pressurized chambers, preventing rapid evaporation. This water could then be piped into underground reservoirs for long-term use. But relying solely on the poles isn't enough. For permanent human habitation, we need to access ice deposits scattered across the planet, especially in more temperate regions where future settlements will be built. Beyond the poles, Mars holds extensive reserves of subsurface ice located just below the dusty topsoil. These ice pockets could be a game changer for future colonists, but extracting them requires careful engineering. First, exploration rovers equipped with ground-penetrating radar would identify the most accessible ice deposits. By analyzing depth, purity, and volume, scientists can determine the best locations for extraction. Once an ice deposit is located, robotic drills or heated boreholes can be deployed to extract ice-laden soil. This material is then transported to a processing unit where it undergoes filtration and purification. From here, the purified water can be distributed to colonial habitats, hydroponic farms, and even fuel production facilities. For settlers, water will first serve basic survival needs: drinking, cooking, and hygiene. But on Mars, every drop counts. Water recycling systems, like those used on the International Space Station, will be crucial for minimizing waste. Growing food on Mars depends entirely on a steady water supply. Instead of soil-based farming, settlers will rely on hydroponic and aeroponic systems, where crops grow in nutrient-rich water solutions, maximizing efficiency. Water isn't just for drinking and farming, it's also a source of rocket fuel. By splitting water molecules through electrolysis, we can produce hydrogen for fuel and oxygen for breathable air, reducing dependence on Earth for supplies. This capability could turn Mars into a fueling station for deeper space exploration, allowing us to reach destinations beyond the red planet. Since early missions will be unmanned, autonomous robots will need to do much of the work, identifying, extracting, and transporting water before human settlers arrive. Water is more than just a necessity. It is the first step toward transforming Mars into a second home for humanity. By unlocking the red planet's frozen reserves, we can grow food, produce fuel, and one day, maybe even create flowing rivers once again. What do you think? Could Mars one day have lakes and rivers again? Let us know in the comments. Don't forget to like and subscribe for more space exploration content.